So here's something that the book covers. Now that we've looked at these limits, or excuse me, we've looked at these derivatives involving logarithms, we can use this to explain the limit definition of the constant number e. E is derived from the limit definition of the ln function when it's evaluated at x equals 1. So this is something, if you're interested in going through, this is the difference quotient for the natural log function evaluated at 1. And ln of 1 is, of course, 0, so it just turns into this. And then, using the property of logarithms, I can take this factor 1 over h and bring it to the power. Right, that's that power property of logarithms. But we also know, so we know that f prime of 1 is equal to this limit, where f of x is the natural log of x. But we also know that f prime of 1 is 1 over x evaluated at 1, which is just 1. So that means this limit is equal to 1. This limit is equal to 1. And then we're going to raise both sides of this equation. We're going to take e and raise each side of this equation, raise e to each side of this equation. And we can do that because e is a one-to-one function. And then we can actually take that limit out of that power and bring it down here because the exponential function is continuous. And remember, there's that property of limits of continuous functions where the limit sign can be brought in and out of the function. That's something we talked about in the previous chapter. So what we have is this. So this is the limit definition of the constant e.